Please introduce yourself and briefly summarize your education and professional background.
Hey, my name is Tristan Schwartzman. I actually started out as an English literature major. I taught English as a second language for a while, then high school math, but it wasn't the career for me. So after a while, I went back to school, got an engineering degree, and switched into the energy field here in the city, which was 12 or 13 years ago now.
Okay, and you're with Goldman Copeland, right?
Yes.
And so what are Goldman Copeland's core services and customers, and what is your role with them?
Goldman Copeland is primarily an MEP consulting engineering firm. So we do mechanical, electric, plumbing equipment for commercial office buildings for the most part, some hospitals, some churches, some universities. But it's basically the air conditioning systems and the other infrastructure. I run the sustainability group. So our group is focused on making sure infrastructure upgrades are do the best they can for the buildings from an energy perspective, and then also making sure that these buildings are improving their performance and in line with local laws and their own sustainability goals.
We're going to talk a bit about some things relevant to New York City, but is Goldman Copeland a countrywide firm, or are you guys mostly based in New York City?
Yeah, so we're a boutique firm. We're focused here. There's a little less than 100 of us. We work primarily in the tri-state area. 70% New York City, a large chunk of New Jersey, and then pick up the others around the corners.
So we're here to talk about New York City's Local Law 97. Can you describe what it is and what it hopes to accomplish, as well as how?
Yeah, so Local Law 97 is basically a carbon cap. So each building, depending upon its size and its occupancy type, is allocated a certain amount of tons of carbon. And then if they use any more than that, they're penalized. There's a financial penalty associated with that. So the goal is to kind of replace general good ideas about optimizing buildings, things that encourage upgrades, with a really concrete final number. This is what you're allowed as a building, and get people to start jumping on board and meeting those requirements.
Okay, and how long has this law been around? I believe it's got a deadline of May 1st, 2025. Is that correct?
Yeah, so the law was passed in 2019, and it gave 5 years for buildings to come into compliance. So the submission is due on May 1st, 2025, but that submission is based on a building's 2024 consumption. So you've already used the energy that you're going to pay your first fine on if you're going to pay your first fine.
Can you tell me a little bit more about how that works and how Goldman Copeland is working with clients so they can comply with the law?
Yeah, so historically we've been pretty engaged with buildings on their energy efficiency. Prior to Local Law 97, there was, in particular, Local Law 87, which dated to 2009, I think. Um, and that was required the buildings to do retro commissioning and a series of things. So those energy audits and retro commissioning projects initially led to a number of energy conservation measures that buildings could implement. Some of them were good ideas, some of them were a little cost prohibitive. As Local Law 97 has come into place, that's moved the bar a bit so that some measures that may have not been practical prior to Local Law 97 now make sense. In particular, anything that moves buildings away from fossil fuels towards electric for heating and production of domestic hot water. What we're trying to do is find a pathway for buildings, because a lot of those measures are very expensive and not necessarily at this point in the technology and available equipment and utility costs practical for buildings. So we're trying to help our clients find a pathway where they can meet the climate, meet the Local Law 97 requirements as those get more and more stringent without breaking the bank.
Sure. Could you describe perhaps an example process, maybe a client that you don't name and something that you did specifically to try and match these laws so they don't have to pay these fines? Like specific examples of something that might happen in one of these cases.
We've got one project that we're rolling out for two separate clients right now, and is a nice, very tidy project that's very targeted toward the local law 97 requirements. So basically, if you take a standard multifamily high rise from not such an old one from the 80s, the 90s, a lot of these buildings will have a fan on the roof that distributes air down through all of the hallways to keep those hallways pressurized. And that pressure pushes the air out toward the rooms, and it provides a little bit of ventilation, and it also prevents stack effect and other kind of comfort issues. So it's a relatively small portion of the building's total heating, maybe 15–20%. And it's cooled via a standard air conditioning unit. It's heated via a gas furnace typically. So you're using gas to warm up the air a little bit so you can dump it in the hallways. So what we're trying to do is replace that unit and tie it into the exhaust systems coming up from the rest of the building so that we can get a little bit of heat recovery off of that and run it through a heat pump instead of gas so that the heat is electrified. Sorry, all this is a little technical, but basically what you come to is you don't have to try to electrify the heat of the entire building, which could be cost prohibitive and isn't necessarily going to save you cash in the short term because gas is cheaper than electric. But you can electrify this one little chunk of this multifamily building, and maybe ends up being 15–20% of the total consumption. And the units on the roof typically have a life of 20 years. So these units just need to get replaced anyway. So when you go to replace the unit, which you have to do anyway, if you replace it with this heat pump instead of the standard unit, the incremental cost difference isn't that much. The electrification benefit is pretty strong, and you're taking strides towards local law 97 without putting yourself in a bad spot.
And so what is Goldman Copeland's role? Like, do you guys then make these suggestions in terms of are they just kind of guidelines or are there actual written engineering documents on what's needed and exactly how much energy will be saved per
Yeah.
unit or installation, things like that?
Yeah. So taking that exact same project that I just mentioned, that started with an energy audit for a specific building where we looked at the equipment and we proposed like a brief scope of work. So it's one measure, it's about 2 pages. It has a little sketch, rough out what more or less the energy savings would be and the installation cost would be, and the incremental difference between a standard installation to give the client an idea of what they would be spending and what the simple payback period would be. Then they're interested, so they opt to move forward. And we then do the design. So we're producing construction documents that are going to go out for bid to contractors, clarifying exactly what has to be done. In the case of that one, that's where we are now. We've just finished the construction documents. It's ready to go out to bid. We are now applying for funding from some of the incentive programs like NYSERDA and Con Edison to support the project, hoping that those incentives make up enough of the incremental difference to enable the client to move the project forward.
And so is there particular software in-house or something that you guys use to create both the energy estimates and the design drawings?
So in both cases, we're going to use something different depending on the complexity of the project. For this one, which is pretty simple from an energy perspective, it's just an Excel spreadsheet. So it's an Excel spreadsheet that has all of the bin data being the temperatures for every individual hour of the year. So we create a spreadsheet that says at different bin data points, you're going to use this much electricity for cooling, this much electricity for heating, this much fan horsepower to move the air around. And then those numbers can all adjust based on the temperature. And we can come up with kind of a bin data analysis of how much energy savings. If we need to, we can use energy models. We have train trace is something we use sometimes, and eQuest is something we use sometimes. But it tends to be, it only makes sense for a really large full building project.
Hmm.
Um, on the drawing side, we typically use AutoCAD. We use Revit where it's very complicated, and then sometimes we'll get into a 3D mapping software so that we can really nail down all the points. But that tends to be um, much larger than just a rooftop unit for a multifamily. That's a project that's feeding one of these 2 million square foot buildings.
Do these come up even before they're designed and built, or are a lot of these kind of existing buildings that trying to retrofit to decrease their carbon?
We focus almost entirely on existing building stock. Like I said, we're an under 100-person firm. We're always working on one or two ground up construction projects, but 90% of what we're doing is the maintenance of the city.
Do you believe that like most buildings that are currently built or recently built are already kind of working toward, these being more sustainable buildings? So it's easy, it's they can build it in the process.
I think that that is more and more true. Since I started in the industry, which, I said 12 or 13 years ago, there's the higher end, larger landowning companies, the big real estate trusts, these sorts of entities have been engaged in sustainability. New construction has been engaged in sustainability. I think there's a lot of kind of pre-war building stock running around New York City that to some extent has been either ignoring the problem or not. um, Again, and I don't want to point a finger. You, everybody needs to support themselves financially. So they maybe don't have as much money to play around with. So they don't have as much money to budget for things like these energy upgrades. I think those sorts of buildings are also getting more and more engaged over the last few years. And there's a lot of avenues for the pre-war buildings with the steam distribution systems to really tune up their heating without breaking the bank and make their way towards 2030 and 2035 compliance requirements.
So was local law 97 kind of created to, I guess, enforce and push those buildings that maybe were kind of ignoring it because they couldn't to make them actually do something?
I believe that it's moved the needle a bit. I think over the last few years, we've seen because of 97, um, perhaps grudgingly, but a movement towards more universal engagement and energy efficiency.
And does the urgency of the upcoming deadline in May 1st, does that have any effect on what you guys are doing and how fast you have to go? Or because this is a year old kind of statistics that it doesn't matter as much anyways?
We're in hyperdrive right now. Just the act of applying alone um, is going to keep my guys running for the next couple months. There's a lot of requirements around assuring that the occupancies are correct, and there's a lot of requirements around assuring that the square footages are correct in these buildings. That's leading to not, I mean, it's not an incredibly intense process, but if you just think about the quantity of buildings in New York City that this law applies to, that there's not enough engineers around to get the job done. So and also all of this work is, all this filing work is just going to disappear as of May 1st. You can get an extension in some cases if you need it, but basically it's all going to just disappear in May 1st. So we can't hire to I mean, Goldman Copeland's not going to hire people and fire them on May 10th. That's not our policy. So everybody's got to run a little extra hard for the next few months so that we can get all the filing done. Um, I think for the most part, our clients that have issues have already know they have issues, and so that's not surprising them. It may be that over the next couple months we find that there's a large chunk of smaller buildings, 25 to 75,000 square feet, maybe that are getting ambushed by this law that really hadn't noticed. Um, but but I think awareness, at least within my clientele, is pretty solid.
Let's get a little more general. So, why are large buildings such an outsized contributor to greenhouse gases?
I think that that statement maybe has some contour to it because if you look at New York City is a huge consumer of energy, but the per capita consumption of individuals living in New York City is not high. Um, you know, we don't drive cars. I mean, I don't live in the city. I drive a car, but people who are living in New York City, they're not driving cars. You're commuting on subways. A lot of the kind of standard energy users that you think of across the United States really aren't factors here, where they are, but not to the same degree. So what you're left with is where people live as the primary consumer of energy. I mean, there are things like the 60s, 70s curtain wall buildings were built as though energy grew on trees. And so they're not the most efficient buildings. They're a little on the leaky side. And so they are in a energy usage index, an EUI, kBTU per square foot. In that context, they are relatively high users of energy. Um, but but at the same time, the pre-war buildings aren't necessarily, especially if they can get their steam systems tuned up. So I don't think you can really say that large buildings are such an outsized contributor. I think it's just that they're the primary contributor since we're not driving around.
So, is then like sealing a building envelope another one of the ways that you can help clients achieve greenhouse gas decreases?
Envelope work is very expensive, but definitely has its place and can be incredibly impactful. Um, Unrelated to really energy at all, but we reclad a building in Midtown Manhattan in 2009, I think it was. Um, and I ran the M&B for that. It was one of the first things I did here. And that building's energy consumption decreased about 30% when it after the recladding. It was very well done. It really sealed everything up, and the building just needed a lot less energy to keep itself hot and cold.
Now, I'd like to get to a little bit of advice to the fellow engineers out there. Let's start with those who might be working in New York to adhere to local law 97. What might some advice be to them on the short deadline that maybe they could use to help their clients achieve some of their goals?
What I'm really pushing my clients to do, and what I would encourage other people to focus on, is um, heating system optimization. We talk a lot about the big talk is electrifying buildings. Electrifying buildings is fine. I don't mind that we would do that, but there's not the capital reserves out there to electrify every building in New York City in the next couple of years. So I think that there's a lot of opportunity left in optimizing heating systems. That's technically challenging because, a steam distribution loop from 1915 has a lot of band-aids associated with it. So it's hard to get to the bottom of it. But I think it's the right path to bring yourself from most buildings being 2025 compliant now. If you want to knock yourself into 2030 compliance, that's a pathway that I believe for most buildings is going to get them there, and you're not going to bankrupt your clients.
Okay, that seems very, very useful and concrete. What about advice for those who aren't in New York City and dealing with such a specific law? Can you pass along perhaps some general best practices others can use in their designs to decrease buildings' greenhouse gas emissions, and particularly for the engineers out there?
A lot of this at this point, especially with new building construction, it's all just in the codes. Really clear control of your outside air, energy recovery wherever you can get it. Um, Transferring heat from here to here in the building, using modern heat pump equipment. All these ideas, they're already out there, they're already around. So I don't think it's a matter of um, doing anything uh, wildly original or incredibly cutting edge. It's just a matter of, I guess, what it's really a matter of is making sure that it's actually constructed properly. So the conceptual design is correct, the actual design is correct, the building is built to the design conditions, the controls in the building operate the way that they're supposed to, the envelope is sealed the way it's supposed to be, and then you'll be there.
And how can engineers help make sure that those things are actually constructed properly? What role do they play in making sure that that happens? Is that follow up? Is that checking that their designs are meeting what's going on in modeling, I guess?
Yeah. Well, so I mean, in New York City, commissioning is required with even the smallest projects. Even a small AC, relatively small AC unit replacement is required to be commissioned. So as long as the commissioning agent is engaged during the design process, keeps engaged through the construction process, and then actually does their job at the end, I think that's a great way to make sure it happens. So a lot of engineering firms have their own commissioning teams. So you can get them looped in from the get-go. And if you focus in on making sure your controls drawings are correct, your commissioning agents involved, and all the other standards are met, then everything, I mean, should work out.
I'm not very familiar with commissioning and commissioning agents. Can you describe what those are just a little bit?
This is a standard for the HVAC industry, certainly. Um, Commissioning agents are kind of run through, create pre-functional checklists to make sure that everything is installed according to design and in line with specifications, and they run everything through functional checks to make sure it functions as it's intended to. So, if a boiler is supposed to produce 130-degree hot water on a 50-degree day, make sure it's producing 130-degree water on a 50-degree day. If that water is supposed to go up to 145 when it goes down to 20, make sure it goes up to 145 when it's down to 120. Just these little details, the commissioning agent is meant to kind of check all those. They create a master repair list or a deficiency list, you can call it either. Actually, master repair list is if it's retro commissioning, deficiency is if it's new commission. Same list though. And that deficiency list is whatever the contractor missed. And so then, the contractor has to go back and fix all those things up. And then there's a little bit of a blame game involved because it could be somebody else's fault. But get through it all and make sure everything's installed the way it's meant to be. So that's what the commissioning does. And then I mentioned that trying to get them involved earlier. So if you involve them at the design phase, they're able to comment on constructability or any other concerns, make recommendations for how the controls could be tuned a little better, things like that, to make sure the project gets off on the right footing. Charles Copeland, who started this company, he keeps a little plaque on his wall that says, "Maintenance is the vitality of civilization." And to me, that's kind of like a running theory of everything I just said to you and what really needs to happen to make buildings perform as well as they can. You can have as many great ideas and new ideas and brand new stuff as you want. But what's really important is that equipment is simple enough that it can be maintained properly and is maintained properly so that things are working the way they're supposed to. If things work the way they're supposed to, you're already halfway there.